So this is the first problem of today's Div 2 CodeChef Starters. And in this problem, we are given that there are in a cricket match there are two teams, each comprising of 11 players, and basically there's a scorecard listing each player, and we have to determine who will be the man of the match. So each run scored by every player earns 1 point, and every wicket taken earns 20 points. So for each of these, we are given how many runs they made and how many wickets they took. So first line is the number of test cases, and the second line, like each test case there are 22 lines, like each player how many. So in this case, this is 1, 2, 3, 4, 5, 6. So like the sixth player would have scored 2 runs, and he has taken 2 wickets. So let's go to 16th. 1, 2, 3, 4, 5, 6. So this one took 68, like he has 68 runs and 3 wickets. So his total score is 98, not 98. Each is 20, right? Each wicket is equivalent to 20 points. So it is 128. So this way we have to decide. So this is a very simple problem. You just have to, like for each play, you have two things. A, B. A is the score. So you just need to add score plus 2 times B, 20 times B. That is the number of wickets. And whoever has this value maximum is your winner. And the winner is decided uniquely. Is it clear? So let me show you the implementation. So this is the implementation. I'm just iterating through these 22 players, and I have already taken the input and scores, which is a pair vector, and for the ith player, this is the score. If the point is more than the maximum points that I have till now, I update my maximum point, and this is my answer. That is the winner. Finally, I can return this winner. Is it clear? Is the implementation clear? Okay, no one is having any doubt in this, right? So let's go to the next problem. So this is the next problem. In this problem, we are given that Arya, the monkey, is trapped inside and into grid. So the grid has n rows numbered from 1 to n from top to bottom, and m columns from 1 to m from left to right. So now we have to find if Arya is initially at x naught comma y naught, and in each move, like Arya can jump from like over L cells in any direction, that is in up, down, left or right. Then we have to find what is the maximum number of distinct cells Arya can reach using 0 or more of these jumps. So let me explain this problem here. Let's say we have this grid. And Arya is initially here. And let's say the jump L is equals to 2. So Arya can go here, Arya can go here and here. So for some like bigger let's say this is the kind of grid. Let's say this is a n cross m matrix, and for this also, let's say RA is initially here, and L is still equal to 2. So this, 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 all of these. So if you see this pattern, this is like these cells also form a kind of rectangle only, right? And what we need to do, we just need to find in this, like the rectangle formed by these cells, how many rows are there, like what is the minimum or the topmost row that Arya can go, and what is the lowest row to which Arya can go. Similarly, on this side also find the first and the last column to which Arya can go. That will give you, like, let's say this is C1, this is C2. So how many columns Arya can go over? C2 minus C1 plus 1. This is 1, 2, 3, 4, 5. This will give you 5. And you'll have to divide it by L, and you'll have to take CL of this. So these are the number of columns to which Arya can go. You just have to multiply this by the same thing, like for rows. So that is, multiply this by R2 minus R1 plus 1 divided by L. Is it clear? That will give you the number of total unique cells that Arya can go. So if someone is asking me to take first example, I'll take that. First test case is just 1, 1, 1, 1, 1. So you don't have to, like, Arya can go nowhere, and it is just one cell. Like first test case is just this thing. So there is one cell, Arya is initially at that, and the jump length is like of one size, but Arya cannot go outside this grid. So just one unique cell which is restricted. Any other doubts, or can I move to the solution implementation? Okay, let's take another test case. So let's take 3, 4, 2, 3, 2. 3, 4. Let's take this thing 3, 4, 2, 3, 2. So 3 rows and 4 columns initially. Initially array is at second row, third column, and two size jump is valid. So Arya can go here. So there are at max 2 unique cells to which Arya can go, because otherwise, if in any of the other directions Arya goes, Arya will end up outside grid from here also. So just these 2 cells. So the answer is 2. Is it clear now? So let me show you the implementation. The formula is just find the leftmost. I'll show you this by here. See, just take n, m, x, y, and l as input. So what is the first row to which you can go? So it is given by, you can do this like this also. See, you are currently at x, and you have to subtract from this some multiple of L, but this should be more than or equals to 1, and this should be less than or equals to n. From this, you can get what is this multiple. Minus L is between this thing and so what is alpha? Alpha is between, alpha is Is it right? Yes, no. So you just have to find how many integers between these two exist. So this is what I was saying. So this will give you the first row and the last row to which Arya can go. Similarly, you have to find the first column and the last column to which Arya can go. And multiply the number of rows and like number of different rows Arya can visit, number of different columns Arya can visit. That is your final answer. So number of different rows Arya can visit is dx. Number of different columns Arya can visit is dy. Just multiply those two. Is it clear? Okay, let's go to the next problem. So in this problem, we are given that Ayush is being interviewed for a executive role in a finance department of a Poroksha IIIT Allahabad annual tech fest. Now, in this, he's given this problem that an integer is called good if, when written in binary, it doesn't contain 101 as a subsequence. So then there are some examples, and now Ayush is given an integer n and he can do the following operations on it. Choose an integer x which is more than or equals to 0 and add 2 to the power x to n. So we have to find the cost for this operation is 2 to the power x, and we have to find the minimum total cost needed to convert n into a good integer. So let me first see what is a good integer. It doesn't have a sequence like 1 0 1 in it. Like the binary representation shouldn't have this. So that means there should be nothing like this. This is not allowed, or this is not allowed, right? This is a sequence. This has a sequence, subsequence of 101. So the only thing that can be is some bunch of ones and surrounded by zeros. Is that making sense? Yes, no. Only this kind of arrangement is possible. Nothing else. Right? Yes, no, anything. Now you are adding, see, initially n will be something like this. So you have to add in the, see, each operation that you'll do, let's say you added this bit, a number which was having this bit. In your answer also, you are adding this thing. So you have to add minimum to this, and whatever you add to this, whatever you add in this is your final answer also. Why? Because if you're adding 2 to the power x, the cost is this much only. And we have to minimize the final cost, so we have to minimize what we are adding. So just add those things that are bit zero between most significant bit and least significant bit. Whatever positions are having unset bit, that you'll have to add here. So that is your final answer. Just add these bits, like the numbers that are corresponding to these bits. Is it making sense? Yes, no? Because eventually we want something like 1 1 1 1 1 1 1 0 0. So this doesn't have 101 as a subsequence. So these are the ones that I have added. So I have just added because I cannot close any bit. Just I can set some bit by adding something. So if I'm adding, I'll make sure that I'm adding at those places which are zeros in between first and last one. Is it making sense? Okay, so let me show you the implementation. So this is the implementation. This is just a 32-bit array for me to know which all bits I'm setting. So first I take my n as input. If then like so I'm finding the most significant bit and the least significant bit which are set in my number. So how to do that? Just iterate from 1 to 32. If the ith bit is set, then most for like the least significant bit is I and just break it. Similarly, find the most significant bit. Like I'm just iterating in reverse direction. So now once I have the most significant bit and the least significant bit, I'm iterating from most significant bit to least significant bit. And if for any time I find out this bit is not set, I'll make my flag as true. Otherwise, if like this was always the case that between most significant and least significant bit, every bit is set, I can just print 0. Otherwise, again iterate from least significant bit to most significant bit. If the bit is 0, then just like this is my index at which I need like I am encountering the zeroth like or the unset bit for the first time. So from this bit to all the bits in future, my bit array is 0, and for all the like this is just simply between most significant and last significant bit, between most significant and last significant bit, all the unset bits are made 1. So all the unset bit between most significant and unset bit are in this. I'm multiplying that thing, like either it will be 1 or 0, either it is true or false. I'm multiplying it with 2 to the power j. Is it clear? Yes, no? Like, see, I'll explain it again. See, you had a number n, and in this, what you have to do, you have to convert it to another number, which in binary form is not having 101 as subsequence. So if you don't want 101 as subsequence, all the ones should occur together, right? So if all the ones should occur together, your zeros at all the places which are having zeros, so that need to be converted to 1. So you'll have to add for these zeros, that is all the zeros between most significant bit and last significant bit. Other than that, like this is the implementation. Now you can implement this in any way you like, just go from most significant bit to last significant bit, and for all these zeros in between, just mark them, like add like the number equivalent to those in your answer. Is it clear now? So going to the next problem. So in this problem, we are given that there is an n cross n matrix B, which is called K strange if it satisfies the following operation. Each integer is between 1 and n square, and every element in B, if it is reduced to B modulo K, then the resulting matrix is symmetric. So now what we have to do, let's suppose Mn is the largest integer for which there exists a Mn strange n into n matrix. So now Sahil has with him an n cross n matrix A, but some of its elements are missing. So what we have to do, we need to find how many different ways there are such that we can fill all the missing values of A such that A is a good matrix. A is a Mn strange matrix, not good matrix. And what was Mn? Mn is the largest integer for which there exists a Mn strange n into n matrix. So whatever this maximum Mn is, we need to convert, like we need to fill these values in A such that the array, the grid A becomes Mn Mn strange matrix. So let me explain this. And we have to finally print the answer modulo 10 to the power 9 plus 7. That is all the way. See, we have an grid like this. And in this, there are some zeros or other numbers are between 1 and n square. So first of all, we have to find Mn. Mn is nothing but for which this is a Mn strange matrix. And what is a K strange matrix? A K strange matrix is something, if you take modulo of all of these values under K, then this is a replica of this. Like these are same under modulo. Under modulo K, this is same as, so this one is diagonal. This needs to be an n cross n, right? So this is equals to this, and this is equals to this. Like you get the idea, right? This is equals to this thing. This is equals to this thing, and similarly, this is equals to this thing under modulo. This one is left. This thing. So this is what is meant by matrix, symmetric matrix. So now, like, is anyone having any idea how to solve this? Like, first, we need to start with the Mn. Like, what is the Mn? What is the Mn? Like, maximum Mn. What is this thing? So, what do you think? How we can do this? See, I'm saying that the value of two numbers is equal under modulo, and since every value is unique in this, every value is unique in this, every value is between 1 and n square. So if two values are giving me same thing under modulo, that means that they are multiple of, like, there is difference. Let's say one value is x, another value is y. So this simply means that x minus y under modulo mn is 0. This is a multiple of this thing. Now I know that, see, if every value is unique in this and I pair these values, these values, these values, so every value is between 1 and n square. So among all of these pairs, it's 100% that for one pair, the minimum value will be between at least more than or equals to, like, how many total pairs there are? N square, not n square, n into n minus 1 by 2. Right? These are the total number of pairs. If I, like, for the symmetric matrix, these are the total number of pairs. Now, the thing is that if my mn is, let's say, if my mn is fixed, then, like, mn is nothing but the maximum k value for which this is a symmetric matrix, like under modulo k. So that thing is, like, where is it? So all my values are between 1 and n square, and what I was saying is that if every value is between 1 and n square and unique, then among all of these pairs, there will be at least one pair for which the minimum of these let's say this is x, or this is alpha and this is beta. like let's say these are the kind of pairs. I am taking my matrix symmetry like with respect to this diagonal. So there will be at least one pair for which minimum of alpha beta is more than this value. This is nothing but the total number of pairs around that diagonal. So if this is true, then this is also true. So if let's say x is bigger than y and every value is unique, my x is, if my y, then my y is basically, so my x is basically n more than. But now there is one more thing. What is it? That this needs to be less than or equals to n square. Right. So this is the constraint that I get, like not x. X is more than or equals to y, y is more than x. So x is at least more than, okay, this thing. So what was my x? My x was nothing but the maximum of these two, like these two pairs. And y is, there is at least one pair for which minimum of these two is more than this thing. So now, can anyone tell me how to proceed further? Like how to get a value of mn? Maximum value for which your array or grid is strange. Anyone? So see, I have come up till like here. Now, if I see my k needs to be less than, like the maximum value that is allowed for k strange matrix is needs to be less than n square. What is it? N square. Like okay, I'll cover this completely. See how n square. Let's not skip this too. See, so up till now, I have come till this point that my x will be less than n square, and on the right hand side, it should be more than equal to n. It should be, where is it? It should be at least more than this thing. See, my y is more than or equals to n into n minus 1 by 2. Y needs to be more than or equals to y is minimum of these two pair, or let's write beta only. Beta needs to be more than, let's say beta is less and alpha is more. So beta is more than or equals to n into n minus 1 by 2. So alpha needs, see, since this condition is meant for alpha and beta also, alpha is, let's say this and beta is this, so alpha beta is a symmetric pair under modular. So alpha is definitely like at least this much more, what, mn more plus beta, at least this much. Then only alpha minus beta is giving you same thing under modular mn, because it's a multiple of mn. Now let's call this k only, maximum k, not k dash. So my k dash is simply like this needs to be, alpha is more than this, but alpha is less than equals to n square. So my k plus beta needs to be less than or equals to, like this condition, I'm taking this condition, needs to be less than or equals to n square. So k needs to be less than or equals to n square minus beta. But what is my beta? Beta is at least more than equals to this thing. So now I can say that my k is less than, that is the maximum value of k that I can choose is So this just gives me an upper bound of what is the maximum value that I can choose for k. K is nothing but under k I'm taking modulo. Like each value will be taken modulo under k. And this is the maximum value for a given value of n. This is important because we have to, like in the problem statement, it's given that first find the maximum mn, which is the maximum value of k, for which under modulo this is the symmetric matrix, and then find all the possible values of filling array or grid A. So we were done with this thing, like this is the maximum value. But how to fill it? Now, filling is very simple. That is, if we look at this array, there are, like this is the grid we are given. We just have to do one thing. See, for an n cross n grid, there will be some values on the diagonal. These values. So these will be exactly n for an n cross n matrix. And what we have to do, see, first of all, we need to, like, how to fill these values. So for filling these values, what we can do, we already know the maximum value of k, and if for some value, let's say k only, or let's not take k, if for some, like, let's concede what values are there which cannot be paired with any. So there are values, let's see, one can be paired with k plus 1. Why? Because if one is here, like eventually these are same under k dash plus 1. If I take modulo under k, this will also give me 1, this will also give me 1. If I have 2 here, I can write k dash plus 2. But what are the values that cannot be paired? Like 2 can be paired with k dash plus 2, 1 can be paired with k dash plus 1, and k is maximum, which is means that k is equals to n square minus n into n plus 1 by 2. So this value is okay. This is the maximum value, right? So now, if this is the maximum value, there will be some things that cannot be paired, like you cannot pair what values you cannot pair. So you cannot pair k minus n plus 1. So why you cannot pair these values? Because if you pair these values, the what should be the, like, if you pair this value k, the next thing, like this is the minimum, the next thing should be 2k, like k plus k, 2k. So this is not allowed because of this, because this will finally exceed n square if you write this thing. So that's why, like similarly, like these also, they are not allowed. So these values should come in between this diagonal, and the remaining value should be like this only. And for each value, we know what is the, if this is 2, this is k plus 2. So we know what is the other pair if it is missing. See, if both of these are missing, then we can fill them in any, let's say these values were missing, these were present but only one. Okay, this is, these circular are absent, and these square, just one is absent, one is present here, one is present here. So in this case, if the values are completely missing, then first let's say there are some p values which are completely, like these pairs are missing. So first I can take a factorial, like either I can decide where these pair would go. So it is p factorial into, I have 2 to the power p. Why? Because either this, let's say alpha will come here, or beta will come here, or beta can come here and alpha can come here. And this needs to be multiplied by, so let's say there are some pairs also, like some pairs for which there are like just one of the values present. So how to fill those? Anyone? Anyone, how can we fill the remaining values? See, like let's suppose if like there needs to be k values on the diagonal, right? Like there needs to be n values on the diagonal. This thing, like if there is like first of all, if there is just one value missing, it is fixed. So there is just one way to fix the like fill this. But about these values, if let's say there needs to be four values, but there are just two values. So for the remaining two values, I have any like two factorial ways. If there were three missing values, then I would have three factorial ways. So basically n minus k factorial ways. So my total answer is n minus k. This is for the center diagonal multiplied by for which both like the complete pair is missing. If the pair is having one value here, then this value is fixed. But if the complete pair is missing, then the number of pairs which are missing is p factorial. Like why? Because alpha beta, let's say I had something like I had grid like this thing. Like alpha beta was missing and gamma delta was also missing. This is my diagonal. So either I can have alpha beta in this, gamma delta in these places, or I could have swapped these also. So if there are p pairs missing, first find p factorial, multiply this with 2 to the power p. Why? Because these can be switched. Similarly, these can be switched in an grid. And this needs to be multiplied by n minus k factorial. Why n minus k factorial? In the center diagonal, there should have been n elements, but there are just k elements. Any doubt? So let me show you the implementation. So in this, I have first taken n as input. Then this is my maximum value of k, for which the grid is symmetric under modulo this value. So I have just created a temporary grid, and in this, I'm taking input. If the current value is 0, that means I have to fill this. Otherwise, if the value is filled, I'm just trying to see that it's symmetric already. If it is not symmetric beforehand, then I can simply print that there are 0 ways to fill array A such that the resulting grid is k strange under maximum k. So this is just those check. Now after this, I am again iterating through my grid, and I'm again checking for the same thing. I'm trying to find the frequency. If any value repeats, then the grid is not k strange. So if any of these values repeat, or any of these values like are like there are three values which are having same thing under modulo m, under modulo k, then also my answer is 0. Otherwise, what I can do, I can simply see what all places are missing values, or how many pairs are missing. Just multiply that factorial. So this is that factorial only from 1 to v1. And let's say like in while explaining, I assume that there are p pairs missing. Let's say there are c pairs missing. So multiply it with c factorial, and finally print your answer. And this high is nothing but this is mod, like whatever the modulo value is, 10 to the power 9 plus 7. Any doubts? Like this is just an observation, or after that it's an implementation problem, simple implementation. Although like there were very few submissions for this during the contest. So that's it, yeah. If you don't have any doubts, we can stop the session.